Hi everyone, my name is Jesus and I'm a PhD student at the University of Porto. Today I will talk about the influence of salinity on non-indigenous fouling species in marine and brackish marinas. The number of recreational marinas has increased in the last years due to the growing demand for leisure boating. Marinas positively impact on local economy by improving tourism, fishing and other services. However, there are several negative impacts associated with their construction and functioning. As we can see here, marinas are often built in soft-bottom areas, and the addition of artificial structures like piles, pontoons, and breakwaters causes an alteration in the type of bottom, changing from a soft bottom to a hard one. The great number of artificial structures in marinas has been associated with a variety of physical disturbances like habitat fragmentation and loss, an increase in sedimentation rate, and a decrease in hydrodynamics and water renewal. This change is also reflected in the inhabiting communities as we observed a shift from soft bottom communities to a hard bottom one that grow in artificial structures, commonly known as fouling community. In this way, marinas provide new habitats to fouling assemblages. These assemblages are dominated by filter feeding animals like bivalves, tunicates, sponges. Here you have some examples. And some of these species can act as ecosystem engineers, providing new habitats for epibionts, which contribute to enhance biodiversity in these degraded areas. There is mounting evidence that species composition of fouling assemblages of marinas is quite different from those found on natural rock reefs. One of the most striking differences between these two habitats is the great abundance and dominance of non-indigenous species in marinas that are commonly transported by recreational boats. Non-indigenous species are considered a source of biocontamination, and they may spread to adjacent natural environments, impacting native biodiversity. Most of the studies about non-indigenous species in marinas are focused on first records. However, there is a lack of quantitative studies dealing with species composition and their main drivers. Salinity is among the most important drivers of fouling assemblages in natural areas. But what about marinas? Therefore, the aim of this study is to test the influence of salinity on the structure of non-indigenous fouling assemblages and biocontamination levels in recreational marinas of northern Portugal. For this, 6 marinas were selected in habitats with 2 different salinity conditions, 3 in brackish areas, the black triangles, and 3 under truly marine salinities, the white squares. Regarding sampling, 3 flooring pontoons were selected at each marina, and the fouling community of 4 random grids was scrapped at each pontoon. Animals were washed, sieved, and fixed, and in the laboratory they were sorted and identified to the lowest taxonomical level possible. The biogeographical status, native, cryptogenic, or non-indigenous, was assessed based on recent and or specialized studies. Cryptogenic and non-indigenous species were considered together for data analysis. Biocontamination levels were assessed through the Site-Specific Biocontamination Index, which is derived from 2 subindices. The Abundance Contamination Index, ACI, that is the ratio between non-indigenous species abundance and total abundance per replicate, and the Richness Contamination Index, RCI, which is the ratio between non-indigenous species richness and total species richness per replicate. With ACI and RCI values, following this matrix, the SBCI is obtained with 5 biocontamination levels that range from 0, no biocontamination, high ecological status, to 4, severe biocontamination, bad ecological status. To explore differences in the structure of non-indigenous fouling assemblages and biocontamination levels between brackish and marine salinities, univariate and multivariate analyses were done. Beginning with the results, 14 cryptogenic and 10 non-indigenous species were found. 13 species were exclusive of marine habitats, 5 exclusive of brackish ones, and 6 species were found in both habitats. Our results show significantly higher values of non-indigenous species richness and 𝗳cie values in marine habitats. However, no difference were found for non-indigenous species abundance and 𝗳cie values. The biocontamination level was also significantly higher in marine habitats, and the ecological status ranged from good to moderate in brackish marinas, on the left chart in green, and from moderate to poor in the marine ones, on the right charts in orange. In addition, non-indigenous assemblage structures significantly differ between brackish and marine habitats, with a dissimilarity of 94%. This differences between the studied habitats can also be observed in the MDA's ordination as a clear separation between marine on the right and brackish marinas on the left. In the table, we have the species responsible for 90% of the difference between habitats. Of these 12 species, only 2 in yellow, 𝗀𝗽𝗲𝗀𝗏𝗀𝗀 𝗀𝗃𝗃 and Sinolobus stanfordi, were exclusive of brackish habitats. The studied assemblages were dominated by 2 arthropods, 𝗀்ξη ◂𝗀𝗀𝗀 and Apocorophyon acutum, and 2 bryothoms, 𝗂ματια gracillima and 𝗀𝗀𝗃𝗂𝗃. To conclude, our results show that salinity is an important driver of non-indigenous fouling assemblages, with higher values of non-indigenous species richness and worse ecological status in marine habitats. These findings are also important for non-indigenous species management. Thus, according to our results, non-indigenous species monitoring and mitigation initiatives should be focused on marine habitats. However, the presence of exclusive non-indigenous species in brackish habitats indicates that marinas and their different salinities should be considered when planning non-indigenous monitoring programs. For more information, you can read our recently published paper in the Diversity Journal. Many thanks to the funders of this study, the Portuguese Foundation for Science and Technology, and thank you all for your time.